All right, good morning. Um, I don't have as much time as I thought because trying to get this thing ready, it glitched out on me and I had to start over. Sorry about that. It might mean I have to go a little faster. I've only got about 25 minutes before I gotta get out of here. So forgive me, but I'm going to go through things a little bit faster. But here's one of your homeworks, and here's all the answers. Um, just pause the video if you need a little more time to look this over. But here's the first couple of derivatives from this worksheet. And I don't have to say much about it. I don't think you guys should be able to look it over. I'll explain the last few problems better. But here's just the answer sheet. And then more answers for this one. You get a radical one and a rational one. And you should be able to just follow along with these to see where you went right or where you went wrong. These problems, like I said in class, I'm not super concerned about. I figured I'd include them anyway. You can read through them at least to see where they were going. But I'm not going to put anything like these on the quiz. But here's 5, 6, and 7, 8. But I wouldn't sweat that. Um, these problems, I like these because they're fast. These problems where you're given sort of the point of tangency and you're given the value of the derivative and all you have to do is plug in to write the equation. I might throw something like this on the quiz just as a couple of quick, like maybe the first and second problem of the quiz, just a quick thing to get you going and get you ready. So make sure you know how to do those. Yeah, and when I say I might put these on the quiz, I even mean something like this, where there's a cosine equation or something. Because notice you don't have to know how to do the derivative of cosine because it's given to you. Same thing over here. You don't need to know that the derivative of tangent was secant squared. It's given to you. You just have to know how to evaluate them. And for the same reason, um, I could include log functions because if I gave you the derivative of the log function, then you should be able to go to town. So suddenly a log would be fair game, an exponential would be fair game. Um, Anything because again we're just getting after that concept of um, the function giving the point of tangency and the derivative giving the slope, and then from there just using the point slope form. Oops. um, Using the point slope form to write the equation. By the way, I didn't want to stop here, so these answers are not quite right for what I was looking for. They're stopping at the y minus y1 equals m times x minus x1. But on the quiz, I will ask you to specifically, rewrite this in points in slope intercept form, and all that means is distributing your slope. So the slope would distribute in, you get 6x minus 24. Then you would add the 50 to both sides, and you would get 6x plus 26 instead. Um, but if I ask you to give your answer in slope intercept form, that just means I want you to plug into the point slope form, but then algebraically just simplify so that you land on that final answer instead. But that's it. All right, so then to the actual quiz review. I gave you guys this answer in class, so I'm not going to go over this very much either because you guys have all seen this one already. But again, just to walk you through the steps, in part A, it says find me an algebraic rule for the rates of change of f of x. If I say rates of change, that means derivative. If I say write a function to model the slopes of the tangent lines, that means derivative. Everything is derivative. And again, you have to use the limit definition. I know a lot of you guys have learned some shortcuts from your pals in AP Calc, but you can't use those. You have to show me this limit definition. You have to plug into the whole f of x plus h minus f of x over h rule. If I don't see that, you're not getting credit. But that's what you see happening here in part A. Speaking of part A, really, really, really make sure that you're labeling your work. Like, show me this is part A, and then do it. And make sure your final answer there is in a box so I can really recognize it. If you can write small enough to keep your work organized, that's going to really be a good thing for partial credit. Okay, so anyway, we found the derivative. Part B says find the coordinates for the point on f of x when x equals 2. That means we're finding the point of tangency. That means we're plugging into the original function f, this one, the quadratic one. It's So that's what you see me doing here. And you give your answer as an ordered pair. Don't tell me the answer is 7 when I ask you for coordinates. The coordinates are 2 comma 7. Then part C says find the rate of change or the slope of the tangent line. That means we're plugging into f prime, the answer that we found in part A. So you see me just doing 6 times 2 makes 12, and I'm labeling that as m just as a reminder that that's our slope. And then finally, find the equation of the line that's tangent to f of x. That means plugging into your point slope form. So our y value from the point of tangency gets plugged in for y1. Remember to leave y alone. Y stays a variable. M gets our slope, so 12 goes in there. And x1 gets the x coordinate of the point of tangency, so that's 2, but leave x alone. Remember, our equation at the end has to have an x and a y in it. And these are the x and y, the x and the y. The x1 and the y1, they take on values, but the x and y, you leave them alone. Anyway, now the next thing to do is just distribute that 12 in. And that's why you see a 12x minus a 24. Then you would add 7 to both sides. And if you add 7 to a negative 24, you land on negative 17. But that's it. That's the final answer. And now I'll actually work through the last 3 with you. But for this one, we have a cubic function. And I'm trying to be nice on the worksheet. I'm giving you the hint that this is what x plus h cubed expands out to. I would not give you that on the quiz. I would expect you to memorize this expansion, because we spent a whole day talking about how to expand not only cubics, but also x plus h to the 4th, and x plus h to the 5th, and x plus h to the 6th. So I would certainly feel fine asking you to do x plus h cubed. The next one is a rational. You've got to be able to do rationals. And the last one is a radical. You've got to be able to do those two. So anyway, let's do this one. I have no idea if I have enough room. Basically just anticipate needing a ton of room and write small if you can, okay, when you get the quiz. The other big thing I would do if I were you is I would get a piece of scrap paper, because if you don't remember how to do x plus h cubed, then over on your scrap paper, you could do x plus h times x plus h times x plus h. You could just do it out the long way. I wouldn't want to see it on your quiz because it would just be a big mess that I don't want to look at. But you should know that x plus h cubed is just x plus h times x plus h times x plus h. And x plus h times x plus h is x plus h squared. And at least you should know that x plus h squared is x squared plus 2xh. Oops, forgot the 2. 2xh plus h squared. And many of you know that now to multiply this x plus h by this quadratic here, you just take the x and distribute it in. So that's an x cubed plus a 2x squared h plus an x h squared, and you're already starting to see this pattern emerge. Then you take the h and distribute that in, and you get an x squared h, which I'll put under this one. And then the h distributes over here. Well, actually into the middle term, you get 2xh squared. I'll put that over here. 2xh squared. And then the h distributes onto the h squared, giving you an h cubed. But if you're afraid that you're not going to remember this expansion, then you can do it out the long way. We're just going to add all of these terms to all of these terms. The x cubed comes down. 2 of these and 1 of these makes 3 x squared h's. And 1 of these and 2 of these makes 3 x h squareds. And an h cubed makes an h cubed. But this is how you can get to this answer if you haven't memorized it. But all of this work, again, I would do that on a piece of scrap paper, because I don't want to look at it. So keep your work clean. So maybe somewhere over here on the side of your desk, you just got a piece of scrap paper. And all this garbage work is on the scrap paper. And when the quiz is over, just throw that piece of scrap away, because I don't care. Alright. But anyway, let's do the actual work now. So what do we know? We know that our first step is to find the derivative of function k. So for part A, we're trying to find k prime. And we know that k prime is going to be the limit as h approaches 0 of this function with x plus h plugged into it. So x plus h cubed minus 3x plus h plus 2. Then we need to subtract from that the original function, which is x cubed minus 3x plus 2. And again, I think a big place where people might make a mistake is just forgetting to put parentheses on this. Remember, we're subtracting the whole thing. We're subtracting all three terms. So put parentheses around that to remind yourself to distribute. Then in the denominator, you just have an h. So now let's start cleaning up. This will be the limit as h approaches 0 still. And in the numerator, we're just going to have a ton of terms. Remember, this guy alone is about to turn into all four of these terms. So we're going to have an x cubed plus 3x squared h plus 3xh squared plus h cubed. Okay, now we're moving on to this guy, which when we distribute will give us two more terms. So minus 3x minus 3h. Then we just have a plus 2, bring that down. A lot of people forget that guy, by the way, so try not to. Then we distribute this negative and we get three more terms. So we get a minus x cubed plus 3x and minus 2. So, okay, that's pretty bad, but it's not the worst thing I've ever seen. It's a lot of terms, but we know that the next step is to cancel a bunch of those terms. And honestly, pretty much any term that doesn't have an h, you're on the lookout for. You're thinking they'll probably cancel. Or, to put it a different way, any term that does have an h, you probably want to keep. So there's an h, there's an h, there's an h. No more h's. So probably all that junk on the end is going to cancel. Let's find out. I see an x cubed, and I see a minus x cubed. So they're gone. I see a minus 3x, and a second minus 3x. Did I screw up? Minus 3x, minus 3h. Yes, I did screw up. This is why it pays to practice, because if you make a mistake, you still know what you're supposed to have gotten, and you can recognize your mistake. That's a 3h. That's my bad. And that means, since he's got an h, he's going to stick around. I thought that looked like too many terms at the end there. That didn't have h at least. Alright, so where's my bright red? So now we've got the 3x here that'll cancel with the plus 3x there. We've got a plus 2 here to cancel with a minus 2 there. And then, yeah, we see it. The only terms left all have h in them, which is good news because one of our main goals, of course, is to get this h in the denominator to cancel so that we can evaluate our limit by substituting in. So let's finally do that. What color do I want to use now? We'll switch over to a dark green. So we haven't substituted in yet, so this is still the limit as h goes to 0. And then upstairs we're going to factor out an h right away. We know we're doing that. So that'll leave me with a 3x squared plus a 3xh plus an h squared and then minus 3. And then of course in the denominator we have our h, and of course we now know that those h's cancel. And it doesn't matter that you've got a few more h's in the numerator. That's fine. That's how we get our final derivative. Don't forget this. The whole point of all this is we're finding k prime. And we now know that k prime is going to be whatever we get when we plug in 0 for h. So the 3x squared, we bring that down, but the 3xh is going to be 3 times x times 0. So that whole term is going to go to 0 and cancel out. The h squared is going to do the same thing because that's now a 0 squared, but we do have a minus 3 on the end. So this thing is a 0, it's basically gone. This is a 0, it's gone. And we see, I'm kind of running out of room here. So we see that our final answer here is that our derivative k prime of x is 3x squared minus 3. And I'll put a box around it. Alright, that took up a lot of space for us, but that's okay. Going back to the top, part B is now asking you to find the coordinates of the point of tangency. Part C is asking you to find the derivative. I don't really care what order we do that in. We've got to do both things, so I don't know. Let's go in order that it's written, I suppose. So why don't we find the point of tangency? That's part B. I'm going to kind of cram part B over here. I don't think it'll be too messy. So to find the point of tangency, we need the original function, f of x. And the original function, f of x, was an x cubed minus 3x plus 2. And again, we want the derivative at our point of tangency, which I don't remember, is just 0. Oh, okay. I said I wasn't going to give you guys zeros, but then I did, which is fine. All right, f of 0. So that'll just be 0 cubed minus 3 times 0 plus 2, which makes this pretty easy. That's obviously 2, which means the coordinates are 0, 2. Okay, that's done. So now we can do part C, which is to find the slope of the tangent line at 0. And to do that, we would want to use our derivative function that we just found in part A. So grab this k prime. Oh, I realize it. I realize my mistake. Remember, these are not f's, these are k's. And that is a mistake that's worth points to me. So remember to call these functions by the proper names. This is function k, not f. Alright, so k prime of x is 3x squared minus 3. And we're after k prime of 0. So we're getting 3 times 0 squared minus 3. Oops. So negative 3. And again, that's our slope. So that's a couple more steps down. And of course, the final step is to actually write the equation of the tangent line. So I'll give myself a little more room for that. But in part D, we're just substituting into the point slope form, the y minus y1 equals m times x minus x1. So y1 is the y coordinate of the point of tangency, so in drops a 2. M is our slope, so we drop in our negative 3. And x is the x coordinate, which is 0. Which means this is kind of an easy one. We get y minus 2 equals negative 3x. And then we add 2 to get y equals negative 3x plus 2. And that's it. That's that whole problem done. Okay, so for the next couple, I'm going to have to go a lot faster because I only have about 7 minutes now. I may even have to, you know what, I am just going to stop from here. I'll have to do the rest later. You guys will have to see the rest tonight. Hopefully what I got for now is good, but I'll put out a part 2 later today. I'm not sure when, but I'll put it out later. Could I at least give you the answers? No, not really. Part 2 will have to do. I'll talk to you guys again later. Bye.